So we got a winch at the top of a 12-meter high building, pulls a pipe of the same length to a vertical position as shown in the figure. The winch pulls in rope at a rate of negative 0.2 meters per second. Okay, yeah, makes sense. Why it's negative? Because S is decreasing, right? That sentence doesn't make sense. It should probably say the winch pulls in rope at a rate of 0.2 meters per second. And it'd be correct to say the rate of S dot is negative 2. You get that? No big deal. Find the rate of vertical change and the rate of horizontal change at the end of the pipe when Y equals 6. Okay, make sense? So we're looking for X dot and Y dot when Y equals 6 in this picture. Okay, so what are we going to do? It's kind of tough one. What are we going to do here?
Write down what we do.
Okay. Yeah. So there's, right, so let's write down, I mean, first things first, we got a picture, let's write down our snapshot stuff. So we know S dot equals negative 0.2, what else do we know?
Y is 12.
Y is 6.
6.
Oh, wait.
So
And we're looking for X dot and Y dot, right? Okay, so we gotta come up with a parent equation.
Like the distance from
How are we gonna do that?
That's fine.
You got some triangles there. Are any of those useful triangles to us?
Yeah, well, yeah.
What do you think?
you can't use a hard figure out the
Pythagorean theorem?
yeah on this one because it's not a right triangle.
Okay, yeah, that's not a right triangle, is it? Right. So we don't like that one. We wanna probably have a right triangle, don't we?
So if you use
I wouldn't use that triangle. I think I would generate a different triangle.
Maybe like 9. Like,
If they want to draw a triangle up here, they think would be useful? Or do you want me to, you think about it a little bit. What do you think?
draw a line from 9 to the top.
The one from
Okay,
X
that's
to Y
good.
down.
So one thing we could do, we could make, I was thinking this triangle up here, but they're the same triangle, right? So we could just go, we could draw a horizontal line here and a vertical line there, and that's good, because now we know some stuff about that. What do we know about the sides of that triangle?
3, 6.
So this is, yeah, this one is, well, it's
No, we
Well,
don't have.
at that point.
at that point, right? So, but what do we know about, the variables are X and Y, aren't they? Right? Can I label sides in this?
Well, the building is 3.
Well, maybe. I mean, you're assuming it's 9, which we don't know.
Yeah.
But what is it for sure? I mean, what's the length of that side for sure? X. Yeah, I mean, it's X, right? That's X, because that's just the X coordinate. There's the origin, right? So that's just the X coordinate of that point, right? Represents the horizontal position of that point. Okay, what's the hypotenuse? S. And what's that side? If that's, well, I'm not gonna tell you, you guys tell me, what is it? Yeah, 12 minus y, isn't it? That distance is 12, and that distance is y, or that distance is y, right? Let's write that down. So that distance right there is y. So it's just 12 minus y, right? We see that?
So why can't you use the 3 since like it's a 12-meter high building and you're at the 9-meter mark?
Yeah, but that says.
Well,
9
we don't,
and
we don't know we're at the
Y is
9-meter mark, because the drawing may not be it's not to scale necessarily, it's just representative, right? And B, even if it was exactly at the 9 meter mark, that's a snapshot. It's
That's
moving,
fine.
right? If I put a 3 there, I'm telling the math gods that value is not changing, but it is. Because as I pull the winch in, the vertical position of the end of that pipe is changing, right? So anything that could vary has to be written as a variable, right?
So could you say that that's 6? Could you just plug in the y is 6 from the?
I can't do that yet because I haven't differentiated yet,
Oh, okay.
right? I can't plug in any values until after I differentiate. Does that make sense why? Okay. So that's all I can do right there. I mean, but that's enough. Look, I've got a relationship then. I know by the Pythagorean theorem, I know what? What's my parent equation?
See 12.
X squared plus
12 minus y squared.
equals.
S squared.
Yeah, that's good, right? That does the job. All we need is a relationship between S and X and Y, right? We got it. Okay. So now we can do calculus. Okay, so then we'll relate the rates by implicitly differentiating. What do we get?
2x x dot.
Plus 2 times the quantity, 12 minus Y to the 1.
Times,
Y.
Just chain rule, right? I've got the derivative of hand squared is 2 times hand to the 1. What's the derivative of 12 minus Y?
wouldn't it be negative y
Just negative Y dot,
right up?
right? Derivative of Y, I've got derivative of 12 is 0. The derivative of negative Y is negative Y dot.
Since it's not a.
There's no power there, right? Equals
2x x dot.
right? Good? Okay, so now I'm just trying to solve for stuff, right? I know, what do I know and what don't I know here? I've got,
S dot y.
yeah, okay, so I want to plug in values now, correct? But, so now I could populate step 1 with more information if I want to, right? So at this moment in time, we know that y is 6, right? So then I could solve, if I know that y is 6, I could solve for x in terms of s and y, couldn't I? You see what I'm saying? I've got a relationship here between x and y and s, right? I know y. Everybody agree? What else do we know? I know, so how can I write an expression for s then, I guess, or for x is what I'm saying. What do you think? If I know that the length of the pipe is 12, right? Okay, you guys have to come up with a way, because when I'm trying to plug stuff in here, look at the problem I've got. Y taken care of. Let's see, S not taken care of, right? S dot taken care of, X dot. I got a lot of stuff there I need to be able to fill in. I've got to be able to find a way to,
Could you
I got to
find,
be able,
could you find x by using trig with the bottom triangle? Like on the other side, like coming
yeah,
down?
right, you might have to use a different triangle, right?
Yeah.
So you see the dilemma we're facing here? let me articulate this a little better. So we've got, let's circle all the unknowns that we've got, right? What are the things that we can't plug in here, right?
X,
We can't plug in X, we can't plug in X dot, we can't plug in Y dot, we can't plug in S, and we can't plug in, that's a lot of stuff, right?
We have S dot.
Oh, we have S dot, never mind, we have S dot. Okay. But we have a lot of stuff there, don't we? Right? Everybody agree?
Mhm.
We have a lot of stuff there, so I've got to be able to find some other relationship here too. And then in calculus or math, we call this a secondary equation. I've got to be able to eliminate some other variables, right? I've got too many variables there. I've got 3 variables, right, that I'm doing calculus on, and so I got to be able to find some other relationship. And you're right, why not just, I used this triangle to relate X and Y and S, but maybe I need a different triangle to relate X and Y. Do you remember the problem we did? And you'll remember this, and hopefully this process will this will kick things loose for you. We did a problem where we had sand falling off a conveyor belt onto a conical pile. Remember that one? And we were asked to find the rate at which the height is changing when the height is something, right? So remember when we did that problem, this is really good. This is going to teach you a lot. We have the parent equation, V equals 1/3 pi r squared h, volume of a right circular pump, right? So when we differentiate that, we got issues because then we've got r's and h's in there, but we only had information about h's, right? They gave us some additional information though. They effectively gave us a secondary equation. They told us that the diameter of the base was equal to 3 times the height or something like that?
Yeah.
Is that right?
Yeah.
So we ended up with like 2r equals 3h. Well, look at that. I've got a way to relate r and h there. So I can, in this case, we were able to just solve for r in terms of h and substitute, and then write our volume as a function of only one variable, right? We could have also, if we wanted to, we could have said, well, okay, well, we could do some other things too. If r equals 3h, if I know the value of h, which we did, I could plug that in and find the corresponding value of r and add that to our snapshot variables, right? We could have also taken this equation and just differentiated and gotten 2r dot equals 3h dot. So I could have even related the rates of change of r and h. Does that make sense? Okay. So what about over here? Let's define a new triangle. What if we take this triangle like right here? Okay, that's a good triangle for us because it only involves 2 variables instead of 3. Everybody see that? It involves the variables x and y. And we know that that hypotenuse is 12 and it's constant, right? So then what's the secondary equation here? What's the relationship between x and y and 12? It's Pythagorean theorem, right? So this tells us that x squared plus y squared equals 144, right? And so already that's a pretty good deal, right? That's allowing us to go back here and say, well, we don't really have any information about x, do we? Right? So I could solve for x in this situation. So x squared, solve for x squared. X squared equals 144 minus y squared. That's pretty useful, isn't it? Where could I use that in my parent equation?
where X is.
Yeah, where x squared is, right? That's great though. Look what that does. That gives us a parent equation with how many variables? 2 instead of 3, right? And 2 that I know something about, y's and s's. Agreed? Okay, so now let's go back and rather than try to just fill in all this additional information and plug in more variables, doesn't it really make more sense here to let's just undo that step 3 that we did and redo it with a simpler parent equation, right? Let's make that substitution. Let's make the substitution 144 minus y squared equals x squared. Now watch what's going to happen with this. This whole problem is you can already kind of see if you look ahead at what you're going to get when you expand this out. Things are going to get a lot easier, right? So this gives us, so if I expand out the quantity 12 minus y squared, what do I get? Oops.
44 minus 24.
Yeah, so I'm gonna get 144 minus 24y plus y squared. Well, that's kind of nice, isn't it? Right? So we get 288 minus 24y equals s squared. Okay? Make sense? Okay? I could then, okay, now what? Differentiate, okay. So step 3, 0, right? Divide both sides by 2. Right? Now what? Okay, we know the value of y, correct? And we know the value of s dot, but when I want to plug stuff in here, I'm trying to solve for y dot. Look, I've got an s dot, but what about my s? Where could I go to find the value of s? Where are y and s related? Because I know something about y, don't I? Y is 6.
Back then.
That is my parent equation, right? My new parent equation relates y and s, doesn't it? So s just equals the square root, we want the positive answer, obviously, right? The square root of the left side, and so I could just make the trade. This guy right here is going to become square root of 288 minus 24y. Or if I wanted to, I could actually just plug in, I could say, okay, yeah, when y equals 6, then what is s, right? And plug it in as a value up here, either way. I always prefer to do it this way and just write the equation in terms of fewer variables and plug in, but take a pick, doesn't matter, right? So does everybody agree then we can find, it's not a big deal to calculate y dot there, because now I can just isolate y dot and plug and chug. Right? We don't even have to do it, but we could, right? That'd be our answer for that part. What about x dot? Where would I go to find x dot then? Because it asks for 2 things, right? So we could get a number for y dot.
Y squared minus, or,
What about that guy? Yeah. I could, if I wanted to, but I shouldn't, but I could go back even to this guy now and differentiate like this guy right here and get x's and x dot, but that's, why do all that stuff? Because now I have enough information that I could plug things in there, right? I know what s is in terms of y, but I mean, that's just a mess, right? Here we got a nice simple relationship between x and y, take advantage of it, right? Our secondary equation, if I differentiate implicitly, what do I get?
2 x dot
Equals,
negative 2y y dot.
right? And so then, if we're trying to find x dot is just negative y dot, both known, because I just found y dot, right? Divided by x, well, I can find x because x is related to y, right? Does it seem easier? I mean, my penchant is once again just to rewrite stuff in terms of fewer variables, but I'm wondering if it would almost make more sense from a beginner's perspective on this to just start adding more values up here to step 1, right? Like, we could have said, right here, we could have said, okay, so now we know what y is, so let's write in a value for, s equals, we got a number, right? See what I'm saying? Now we got that number, that allows us to find out what y dot is. And so y dot, we're gonna get a number for y dot. We're starting to populate that, fill in more stuff. And it's like those puzzles, you know, where once the pieces start to fit in place, everything kind of comes together. Then we go over here, and we could use this equation right here to solve, we didn't even color here. We could use this equation to plug in a value for x equals something, right? And then once I know what that is, now finally I can get x dot in terms of all this stuff, and then I can nail down x dot, right? Does that process make sense? Okay, that's a pretty hard one. I mean, there's a lot of moving parts in that one. Needing that secondary equation makes it a little trickier, right? Okay, you get the idea though? Okay. Should move on. We don't want to do all the. We just don't want to plug in numbers, do this. It's gonna take a little while. We'll skip that. That's boring. Let's do something different here. Let's find another one. That was the fun part. Air traffic control. Oh, that's kind of cool.
Well, 22 degrees south. Nah, I think that's what you first plane to take off.
No, first plane.
Okay, so what about this guy? Yeah, I like that. That's good. That's good. Let's at least just talk about the fun parts, you know, how we could do this one. We have to maybe do all the. Okay, there we are. So what do we got here? One plane is 225 miles from the point moving at, there's the point, right? Where the air traffic controller is. Or they're converging on a point. 225 miles from the point moving at 450 miles per hour towards it. The other one is 300 miles away from the point, moving at 600 miles per hour. At what rate is the distance between the planes decreasing? Okay, so same kind of a deal, isn't it? This one's a little easier though. We only need one triangle for this. What's our relationship? This is a pretty quick one. What do we know? What's our step one? What do we? X equals
225.
X dot equals
450.
what is it? Negative 450. Y equals
300. Negative 6.
Negative 6.
okay. And what are we trying to find here? We're trying to find S dot. Yeah, S dot. Okay. Okay. What's our apparent equation?
X squared minus y squared equals s squared.
Yeah. So x squared.
2 minus x dot
What's that?
equals 2 minus x dot. Great discussion.
So two X, X dot,
It's two
two
Y, Y
two
dot.
Y,
Y dot
Y
equals
dot
two S,
equals
S dot.
two S, S dot.
I don't know, oh, we got.
So-
Divided by 2A.
Yeah.
Quarter.
Okay, and S is really just the square root of X squared plus Y squared, right?
Yeah.
Okay. Okay, so there's our stuff, and if we wanna know at what rate is the distance between the planes decreasing, well, it's decreasing at that rate, isn't it? Right? So what could we do then if we wanted to write this as a function? Right, we could write this as a function of, like, maybe the x, right, the position of the first plane. Okay. What's constant up here in that? X dot and Y dot are constant, aren't they? Right? X and Y are not. Okay, so then we could write this as X times negative, what was that one, 450?
Yep.
Oops. Minus 600, was it? Okay, so that's S dot, right? S dot is not constant. Okay, so how am I going to write this? How am I gonna write this then? If I don't know values, well, I do know values of X and Y. At that, so I wanna make this a better problem. So at this one snapshot, we can just plug in values, can't we?
Yeah.
Okay, everybody see that? We can plug in 225 and 300. Somebody in your calculator real quick, let's get that answer, right? So we get, I guess I'll put my calculator up. Okay, so we got the expression, the quantity, negative 450 times X was 225, right?
Yeah.
Minus 600 times 300?
Yeah.
Divided by 2, yeah, square root of, oops, what did I do? Divided by the quantity, square root of 225 squared plus 300 squared. Okay, enter. So the planes are approaching each other at a rate of 750 miles per hour. Okay. So that's the answer to part A. How much time does the air traffic controller have to get one of the planes on a different flight path? How are you gonna do that problem? be problem solvers, because this one is, there's a bunch of ways you could answer this question. It's not like there's just like, you're gonna do some more calculus and get an answer out of this. You have to interpret some stuff. We kinda did the related rates problem right there. That was the typical related rates problem, where we wanna know what's S dot at that frame in the movie. Okay, answered it, check it off. But what are you gonna do if you're the air traffic controller up there and you're trying to figure out how much time you got?
Can you plug in X, Y, and S is 0?
You could,
Is that a thing?
okay, so you've got this equation, you're trying to figure out when they're going to crash into each other, right? And so really in this case, what you're trying to find is when is S equal to 0, right? Okay. Doing the related rates here didn't necessarily help you with that very much, did it? Right? Because there's a bunch of stuff. If I wanted to solve for X as a function of time, look, I've got this other variable in there, Y, as a function of time. I've got S as a function of time, right? So you're kind of stuck. So you might have to abandon the calculus on this one a little bit.
It's just half an hour,
How'd you get that?
because X is 225, so it's 225 miles out, but it's going at 450,
Exactly.
so it's gonna take half.
Yeah.
And then the other one's.
So if you're the air traffic controller, you got to get this done. You're gonna say, okay, well let's calculate when are these planes, right? I mean, this really doesn't end up being a calculus question. You're just saying, okay, how long does it take for that first plane to get to the point? Well, that's pretty simple. Right? If it's 225 miles away, traveling at 450 miles per hour, then 225 divided by 450 is 0.5 hours. Okay. I guess you'd probably then look at the other plane and say, are we going to have a problem? Is it going to get to that point at the same time?
Well, of course, it's math.
Find out. Yeah, it looks like it is, isn't it? Right? And because it's 300 miles away, moving at 600 miles per hour, and so okay, there's an issue, but we know how much time until that happens. It's half an hour, right? Make sense? Okay.
I like that one.
Yeah.
Put that one on the test.
No, I don't want the test. It's kind of a good question though.
Yeah, it's a good, great question.
Like, Trump's playing Air Force One right now.
See if there's anything we're missing.
Stop.
Oh, there's electricity.
All of them. Answer all the above.
Oh, I love it. Okay, calculating resistance of parallel circuits. I like that.
Oh,
The resistances are changing. Say that the resistors are heating up and the resistors are changing.
41, that's the real one.
Yeah. How is the overall resistance, the impedance of the circuit changing? So that'd be a good one to do. I like that. Hey, how we doing?
Not too bad, how about you?
Good. You missed some kind of fun.
Where you been?
Way to get there early.
What? What are you doing?
What are you doing?
Yeah, what are you
Is the
doing?
real question.